So we're going to talk about the types of wiring that is actually in your house, the circuits that you create in your house, and then also talk about the idea of fuses and circuit breakers and the positives and negatives to both. So first, your household wiring. So do you think it's going to be parallel or series? Well, going to be parallel. The reason why is you don't have to have your toaster on for the refrigerator to run, and you don't have to have the washing machine on to dry your hair in the bathroom. So each object is on its own circuit, so its own loop, hence parallel. But what happens if you plug in too many things? So each connection will use what it needs. And so what we're talking about here is the current. Every plug is 120 volts, and each appliance, since it's in parallel, is going to pull the current that it needs to run. This is why sometimes whenever you turn on your hair dryer, the lights will slightly dim, or whenever the heater kicks on, the lights will slightly dim. The reason why is because it's not a perfect parallel connection. There is only so much push that is coming into your house, and so if it's spread out over too many very, very high wattage appliances, then it can cause that slight dimming to happen. So eventually, more current will be used than the wires can carry, and that's when you have overheating. That's when you can have house fires. So if your wiring is good in your house, if there's too much current going through, then your circuit breaker will click open. So that's the big box that's either in the laundry room, in the garage, in your basement, somewhere like that where there's a whole bunch of switches. And so what happens is the switch will click over if too much current goes through, and that's why you have to go down to the basement or the laundry room and flip it back before you can use electricity. It's a safety mechanism. So let's talk about how fires can happen because of current. So first of all, current flowing causes heat. Anyone who has used a computer, which I know every one of you has, a computer will get hot while it's running. And it's because inherently there's resistance in wires. And so all of this current is going through. There's some slight resistance. It causes heating. But if too much heat is produced because of too much current, you can have a house fire. You don't want that. So instead, your house is set up to have these safeties to help you out. So your house has a circuit breaker. Your car and other like handheld devices and things have fuses. So the way a fuse works is it's literally a very, very thin wire, and if too much current goes through, it gets too hot and it'll actually melt and break. And whenever the fuse breaks, there's a break in the circuit, and so electricity stops flowing. Nothing will flow again until you put a new fuse in. So once the new fuse goes in, then current will continue to flow. These are very useful because they're very small, and so they're very portable. That's why your car uses fuses. Houses used to be on fuses, but the problem is the size of the fuse used to be about the size of a penny. And so they were called penny fuses. So what some people would do is, let's say it was like middle of the night that a fuse popped and you don't have any extras. Well, you want your electricity. So they would stick a penny in it, and the penny would flow, would allow the current to flow through because copper is a good conductor. But the problem is the penny wouldn't break. So if too much current was going through a wire in the house, there wasn't a real fuse there to break. And so house fires became horrible whenever electricity was really, really common in houses because people were not actually replacing their fuses with fuses. So instead they came up with this idea of circuit breakers. And so this is the panel you've probably seen in your basement, in your laundry room, in the garage where you have a whole bunch of switches. So these are better than fuses for a house because if too much current goes through, the little switch just flips over. And so all you have to do, whether it's in the morning, during the day, or in the middle of the night, is you just go back and you flip the switch back on, and everything goes back to normal. So the breakers are like switches. So they're like on-off switches that open and close the circuit. And so if too much current goes through, it switches open, which means it stops the flow. The other nice thing about these is if they flip, you don't have to replace them immediately. So circuit breakers can actually last for like 15, 20 years before they have to be replaced. But they do eventually need to be replaced because the components in those breaker boxes will eventually wear out. But it's much better than every single time you try to blow your hair, you blow a fuse, you have to put a new one in. Instead, you flip the switch back and forth for 20 years, and then eventually it needs to be replaced. So much more durable. Now, the problem with this for, say, portable things like your car or handheld electronics is this is huge. And one of those boxes is a pretty good size. It's about the size of a cell phone and about an inch thick. So you can imagine trying to carry something like that for each individual thing that needs some sort of protection would become very heavy, would become very large. So portable things still use fuses because they're very portable. Houses are now on circuit breakers so that it's actually reduced, like significantly reduced the number of fires.